So let's continue on with IA 210 Robotics, Chapter 8 Review. Notice we skipped Chapter 7 Fluid Power. That's because it's not that pertinent to what we're doing here. Chapter 8 talks about sensors, and sensors are critical for robotics and more critical as time goes on. It used to be that older robotic systems only had a handful of sensors integrated, and you'll see that the older robots like the Escalas, integrating sensors was difficult. You only had maybe 8 or 16 inputs or outputs to use, and you had limited functionality for them in the systems. But new robotics make it a lot easier to hook in the sensors, and there are many systems now with very complex integration of sensors, PLCs, and robots. So this chapter is not super good in describing how the sensors are used in every case, but it does do a good job if you haven't taken any of these sensors classes before of describing different kind of sensors out there. So let's dive into it. In general, a sensor is something that converts, it's a conversion, a device that converts light, heat, or mechanical energy into electrical energy. Now, the generic term for that is a transducer. However, the thing that makes it a sensor is it then converts that electrical energy into something that can be used as an input to another system like a robot or a PLC. And they give you an example of a thermocouple as a sensor. A thermocouple transmits a different voltage depending on how hot it is. So it's converting heat energy into an electrical energy, a voltage, and so forth. So the transducer is the word. It's just a device that converts some sort of energy into an electrical signal. And there's a lot of different kind of transducers out there. And I'm not going to read through all of these for you. They're all using basic electrical kind of aspects, electrical measurement techniques, and converting it to a sensing device. Resistive transducers are something where somehow a physical change in the world changes the resistance in an electrical signal. And a typical example of that is a potentiometer. In our electronics course, we've got a potentiometer, which is simply a little dial device. And here I've got my electronics course baggie full of my parts. And this is a potentiometer. And all you do here is you twist this little knob and it changes resistance in the potentiometer so that if you hook that up to a computer, you can see a change in resistance. Of course, you'll need an energy source as well. That's an example of a resistance transducer. And there's a lot of ways of using resistance in various sensors. We also have capacitive sensors. And this is a classic one if you're talking about a capacitive sensor for measuring whether a part is there or not. We can use the changing capacitance as a way of changing a part or changing the electrical signal to a PLC to say if a part's there or not. We also have inductive sensors or transducers. So the change in electromagnetic kind of constant in a given area. Like, for instance, you bring a big chunk of steel up against the sensor, that changes the electromagnetic field, and then we can measure that. So these are all classic ways of using electricity to give us a signal change, and that change in physical environment then can be converted to a electrical change. And here on the right, they show you 3 kind of very simplistic examples of how that might work, and you could take a look at those on your own. And they even show you a potentiometric transducer using a flat strip. So these are just sort of high-level conceptual ideas behind sensors. Not that important to understand from a robotic standpoint, but useful from a, I guess, useful from a terminology standpoint. So typical types of sensors. Light sensors are very common. We use light sensors a lot in PLC systems as sensors for whether an object is there or not. If you cross through a light beam, you know an object is there because your light signal turns off, right? That's a typical one. If you have a light sensor that's got special ability, it can bounce its light energy against a sheet of paper, and it could tell if that paper is there or not, or if the paper is a different color than it should be. So these are all different methods of using light waves to determine, whether something is there or not. And they mention a few different methods, and they give you some high-level terms on how light works. And they talk about how a basic photovoltaic cell works, and that way a little bit of light energy directly hitting a photovoltaic cell directly creates voltage, so it makes it almost the perfect sensor in terms of light. However, we all know that all you do is shine light on a LED, and the LED can generate a little voltage too. So even an LED can be used as a sensor. And it gives you a few more details about different kind of light sensor wavelengths, as well as some key useful things like fiber optics, where you can send light down a wire. So if your electronics are sensitive, you can send a fiber optic cable down into an area that might be very dangerous for your electronics. And lasers are just a form of light. In this case, it's light that's lined horizontally. Amplified stimulated emission of radiation, laser. You should know what these terms mean. We also have what they called semiconductor lasers. In fact, we've got one of those on our blue robots from Yaskawa. They're not very great lasers, but they work okay. Vision sensors. It just talks super high level about vision sensors. The idea that you can hook a camera up to a small control system, and then the camera can be snapping pictures and analyzing those pictures to determine whether or not you found a part or if the part's got some problems with it. Sound sensors, if something's made a sound or not. Temperature, we've talked about thermocouples. Yeah, these are all pretty obvious. Magnetic field sensors. Typically, they're used in inductive proximity sensors internally, but you can buy relatively cheap field sensors as well. It doesn't really get down to some solid data until page 250 in section 8.3, where we talk about sensor applications. A typical sensor application in robotics is speed/position sensors, which are your encoders on the back end of all of your motors. But at this part in the chapter, they're mostly talking about simple tachometers, the kind you might have in your automobile to measure the rotational speed of, say, your engine. We also have mechanical movement sensors. Typically, they're used. Strain gauge is something that's used in type of a lot of other sensors, but anything that can physically change once you change a position is considered a mechanical movement sensor, and there's dozens of different kinds out there. Proximity sensors don't have to touch it. That means you have to get in proximity of the object. We know that in our sensors class, we've got what's called capacitive proximity sensors as well as inductive. So in one case, capacitive, it's measuring the change in the dielectric component or the capacity of the air around that sensor. So put your hand near it, you can turn it on, or a plastic block or wood or anything, where an inductive sensor only turns on if something metal goes near it. Here they show you a picture of what a strain gauge looks like, which is basically a thin wire on a plate. And when you bend that plate, you increase the resistance. They show you an obvious sensor, which is a limit switch, and there's thousands of limit switch types out there, and each one of them might have a different actuator, a paddle, a push button. There's dozens and dozens of styles. And it just goes through a long list of different sensors here. It's really not any rhyme or reason to this chapter.